Okay, so welcome to my talk, which is infrastructure as software. So infrastructure as software is a talk that is related to using the tooling in order to build your systems into the cloud. My name is Paul Stack. I'm Stack72, and I work for a company called Pulumi. Everything you see today is open source. I'm not going to ask you to pay for anything, but the examples that I am giving will show you Pulumi as a tool. So different companies, different people are at different levels of a cloud transition. There are notoriously three different levels. So we have V1, which is like traditional N-tier style architectures that have been pushed to the cloud. So you just think that you've picked up your physical data center and moved it to the cloud. You have some application servers, you have some web servers. They're long managed. They're usually managed by a configuration management tool, maybe Puppet, maybe Chef, maybe Ansible, maybe something like this. And they're longer running tools that you sort of care for in a little way. Then you move into V2. V2 is a little bit of a more transitional style. So it's a little bit of N-tier style architecture, but using managed services, maybe hosted SQL Server or Aurora in AWS, maybe taking advantage of containers like Docker, and your systems start to become a little bit more ephemeral. So effectively, you can much more move into the immutable style infrastructures where infrastructures can be created and destroyed, and they don't really have long running state held within the application themselves, because you know that that's sort of a little bit dangerous when you go to the cloud. And then you have V3 infrastructures. These are what we class as modern infrastructures. You've probably heard the term cloud native or microservices or all these different things. And this is what we mean by the modern infrastructure. So you're probably using a container scheduler, maybe Kubernetes, maybe HashiCorp Nomad. You're taking advantage of maybe serverless. You're taking advantage of hosted monitoring tools that are feeding back into your code, and everything is sort of fully dynamic, and it's very difficult to get each and every piece running because there are so many different pieces of your system. If you think of it in terms of microservices, you could have 5,000 microservices running within your system, but to run all 5,000 on your developer laptop would be very difficult. So there are different ecosystems, and different parts of the ecosystem, and different people are at different levels. So I'm not saying that if you're not at V3, you're not doing the right thing. That's really not the point of this talk. All of the tooling that exists today, and I do mean all of the tooling, so we're talking CloudFormation, we're talking ARM templates, we're talking HashiCorp Terraform, we're talking Pulumi, we're talking Puppet, we're talking Ansible, they target specific levels or a combination of levels of all of the transitions. But we at Pulumi believe that we're very much targeting V3 because we're taking advantage of real languages in order to understand and build sort of these dynamic architectures as we go. And I'll show you that as we go through. So just to get everybody on the same page, what is infrastructure as code? It's a way of eliminating error-prone manual changes. It's a way of bringing your best practices to infrastructure, and you gain visibility through code reviews and previews. So you're codifying your infrastructure. It's automated and it's repeatable, and it's faster to get to market. And because it is actually got plans and previews, it's actually safe and predictable. So it's a declarative syntax. Whereas at Pulumi, we believe that we're actually modern infrastructure as code because we use real languages. You get to create layers of abstraction. So real APIs, real packages. You can use your favorite tools, your IDEs, your testing. You can deploy it. You have a CLI, which for your GitOps interaction, which hooks into your CI/CD workflow. And of course, because of that, you can audit all your changes that go with it across all the other tools as well. So for us, we don't believe that it's infrastructure as code. We actually believe that it's infrastructure as software. Because we're using real languages, we can actually take advantage of the real language ecosystems, and we can start to actually really build in proper development practices into our infrastructure. We no longer have to have these rubbish bash scripts or really nasty JSON files or DSL files that have grown and not been given care and attention. We believe that you can actually create real software in the same way that you would create your real application. Infrastructure code is just as important as application code, because without the infrastructure code, you can't deploy your application. So you need to treat it with the same care and respect. So Pulumi has a number of layers that allow you to do this. So let's start at the bottom, and we will say that it has a layer of providers. This is our foundation, everything's built upon. So we have access to the SDKs and the APIs for AWS, Azure, Google Cloud, Kubernetes, OpenStack, DigitalOcean, VMware, Datadog, Cloudflare, New Relic, and so many more tools. And because we have that, you can create raw infrastructure against those pieces of those vendors or those specific clouds. Then because of that, we can create libraries on top of those, which will actually be layers of abstraction, which allow you to interact with containers or serverless or infrastructure. And then as at Pulumi, we have developed this idea called Crosswalk, where we have created the best practices in the simplest way in order to make people as productive as possible. So I'll give you an example of Crosswalk in action. To create a fully working VPC in Amazon, so a VPC is your own virtual private cloud, you would need the VPC, you would need the subnets that go with it, you would need the internet gateway, you would need, if it was private subnets, you'd need the route tables and the route table associations that allow you to talk into the private subnets, and then you would need some NAT gateways, which would actually allow your private subnets to talk out to the internet. Now, there's a lot of boilerplate code there, and we've actually been able to wrap that away in a single line of code, which will actually take care of that for you. And I can show you that in a demonstration very shortly. So I said Pulumi is modern infrastructure as code that allows you to take advantage of your existing tools in your existing ecosystem. So we support, of course, all major source code providers. I'm not saying these are the only ones. Of course, these are the ones that we have most usage from. So GitHub, Atlassian, GitLab, VSTS. We support JavaScript and TypeScript. We support Python. We support Go, and we support all of the .NET core ecosystem languages. So C#, F#, and VB. We are real languages, therefore we can take advantage of NPM, we can take advantage of NuGet, we can take advantage of Pipey, we can hook into CI/CD systems. And then, as I said previously, we actually have support for AWS, Azure, GCP, Kubernetes, OpenStack, DigitalOcean, Packet.net, and so many other clouds. So it's important to understand that even though it's using real languages, Pulumi is declarative by default. It is actually end state that you declare. So in this small application, you will see in TypeScript, you would declare that you want a security group with these ingress rules. You would declare that you need this specific instance and using the specific security group that goes with it, and the AMI, of course, that we set as a constant. But because it's an imperative application, you need to understand and create the correct application structure that will allow you to run it. Because in this case, in JavaScript, if I was to try and declare the instance before the security group, then of course that's not a correct application structure, and it would actually fail to compile. So it's really giving you the ability to create that end state configuration in an imperative manner. It has, of course, got support for loops and conditions and real programming constructs. So in this example, we only provision a VPC if there's, a VPC and public subnets if there's a CIDR block for them. Okay, so you can start to take advantage of understanding the conditionals that are happening in your system. We have multi-provider workflows where the output of one resource can be the input of another resource. You'll see that the Nginx, the constant bucket will actually store our Nginx configuration, and that is then actually passed into your Kubernetes deployment in the spec. So you can see bucket.bucket domain name. We have reusability, so you can actually package things up into your own APIs. So your operations team can create APIs around networking or around Kubernetes or around these areas that you as developers are not so caring about. You don't care about how to build a Kubernetes cluster. You need a Kubernetes cluster in your environment that you can actually start to deploy your applications onto to test your applications. So we can actually allow you to package them up within your environment and reuse those. And then we can start to do much more interesting things. So this is an example of advanced orchestration. So what this code is doing right now is it is creating 3 replicas of a deployment. So we're going to call that our canary. After the 3 replicas have been created, It will then go off to check Prometheus. Because it's real code, we can actually import the Prometheus SDK package, or we can actually talk out to the Prometheus API directly. Once we're happy inside this check app metrics function, once we're happy that everything works as expected, then we can actually proceed with the next 10 replicas of our cluster. So no more blue-green deploys or canary rollouts that would actually allow you to talk to, do one half, then go off and manually look at some graphs and then come back and hope everything is okay and then manually deploy the rest. This would actually allow you to encompass everything within the same application. One of the new things that we've actually added in Pulumi 2.0, which was released maybe a month ago now, maybe a month and a half, is the ability to have real test-driven infrastructure. So infrastructure testing is hard because the feedback loop is extremely slow, because you actually have to wait on resources to spin up and understand what's happening. But if we think about that, what we're doing there is we're testing that the API request that we've sent to our specific cloud is actually valid after it has spun up the infrastructure. So we know that if we give a cloud a specific request, that they will give us a well-formed response. So in Pulumi, we can actually mock that response right now. And we can actually say, hey, if there's a request to create a new resource, if it's a resource of this specific type, then we can mock that the response from the cloud would be X. If it is of another type, it will be response Y. If it's another type, it will be response Z. And because of that, we can then actually test that our code works, not the actual cloud themselves. Because most of the time, our tests are actually testing that it's the cloud rather than our specific code that's been written. And my favorite feature about Pulumi is the secrets management. Infrastructure as code tooling has predominantly not had secrets management as a first-class member throughout the years. We've usually had to use another tool that goes with it, or it's been bolted on throughout time. But Pulumi was actually built with secrets management built in by default. So we will take care of secret management for you when you create a project, and I will show you that very soon. And it actually allows you to integrate with existing providers that you have. If you don't use AWS KMS or Azure Key Vault or Google Cloud KMS or HashiCorp Vault, then Pulumi will assign a Pulumi KMS key to your project, and it will use that, which under the hood is using AWS KMS, and you don't have to worry about setting up the infrastructure for it. But of course, you can bring your own, and bringing your own will adhere to your own security protocols within your organization. This is one of my favorite features, and it's one of the first ones I'm going to demo. Super fast, just to talk about the internals of Pulumi. Pulumi is a client and CLI, okay? The CLI tool on your local machine or on your CI tool will read the credentials. It will not transport the credentials anywhere else. So the CLI makes two calls. It makes a call to your cloud when it actually has the API call, and it of course does that over HTTPS, and it will authenticate correctly against the cloud. And then it will actually talk to api.pulumi.com or app.pulumi.com to store your state. That's only the metadata. The metadata does not include your credentials. We never leak those off the local machine. Or you do not have to use the Pulumi SaaS. What you can actually do is you can use an S3 bucket or a GCP bucket or an Azure blob, and you can log in very quickly and store your state there, so you don't even have to talk to Pulumi in any way, shape, or form. It's really important. I think someone may have had a question because I heard a beep. If someone has a question on that, please do ask it. Nope, I'll continue on. So let's go and actually start writing some code so that we can see this in action. Now, it's really important to know here that just before I started this talk, Amazon have started having API error rates. So my demo may be interesting, but we shall see if it is interesting or not. So let's go and have a look at it. So I created just a folder. There's nothing in the folder, absolutely zero in here. And the first thing is that Pulumi is a CLI, I told you. So if I run Pulumi, it will give us all of the available commands in Pulumi. But what it actually does is it says the most popular commands that people used or they begin working with is Pulumi new, Pulumi up, stack, configure, destroy, and then it has all of the other ones. So Pulumi new is by default, Pulumi is by default an interactive CLI. So if we run the command Pulumi new, it will give us a list of pre-scaffolded templates that actually have everything, all of the dependencies required in order to run a Pulumi application. So today I'm going to choose AWS TypeScript. I've given this demo like 100 times in AWS TypeScript, and it'll be the fastest to show you a lot of good information. So we're going to call it NDC Oslo. You can give it a description, and then it'll ask you, do you want the stack? So stacks in Pulumi, you can think of a stack as an environment. So dev, testing, staging, production, but you can also think of a stack as each individual developer can have their own stack. A stack is a way of managing a state for a group of resources, and you can have multiple stacks pointing to the same project. So this is what allows you to deploy independently of each other, and each stack can have its own configuration. So if you think that your production stack needs one set of credentials, your dev stack needs a different set of credentials, and this is actually how we take care of it. So we're just going to say dev because we're not going to get into multiple stacks today. And then it'll ask us a region. So I'm going to say US West 2 because I know that every demo that I give today works in US West 2 or should work in US West 2. And then of course it's JavaScript, so it's going to download and install the entire internet. So that is an entire Pulumi application that has been scaffolded. So let's go and write some code. Okay, so I'm just going to open my IDE very fast. And we can see in presentation mode, I apologize. And what it's given us is a number of things. Firstly, it has all of our node modules. Okay, it has a git ignore, it has index.ts, which we'll come back to, our package.json, okay, which has our dependencies. It has a Pulumi.yaml. Okay, this is the description of the Pulumi project, including the runtime. So if we change the runtime to .NET, it would actually run C# or F# or whatever. And then lastly, it has a Pulumi.stack.yaml file. So in this case, we chose dev, so it's a dev file. The dev file can have config US West 2. The prod file can have config US East 1, for example, as a region in AWS. And then lastly, it has our index.ts. So it has three different things in our index.ts. First, it has our imports. So if you think of these like our packages, so Pulumi being the helpers, the actual engine, access to the Pulumi engine itself, AWS being the raw providers, and AWS X being that crosswalk compatible API that sits across the top. And then we can actually write some programs against this. So everything in our cloud, and I'm using Amazon here, the same style of demo can be given to Azure, and you would have the same style of packages. So we have aws.s3.bucket, or I can say const x equals new aws.rds, which is the database component, and we would actually see that it's an instance. So we get full autocomplete because of the fact that we are a typed language. Now, for anyone who is watching the talk, if you're a JavaScript person, please do not laugh at my JavaScript. I am not a JavaScript developer, but this actually is extremely simple to get going with Pulumi. So that is everything. That is a working Pulumi application. And if I envchain, which is, I use a tool for managing my credentials locally. And if I say envchain, this just loads my credentials. Pulumi up, what Pulumi will do is it will try and create a plan of what it's going to do. So the first thing it says is it's going to create a dev stack because it doesn't exist right now. And as part of that dev stack, it will create a number of resources. Now, the resources in this case will only be an S3 bucket and nothing else. And we can have a look at the details of what it's going to do. Now, there's one interesting thing to note right here, is the bucket that it's going to deploy has a suffix on the name. Pulumi by default will take the constructor name, add a random suffix to it, and that would be the name of the resource by default. We employ auto naming by default because we try and allow you the ability to create before destroy in the cloud. There are lots of resources. Let's say storage accounts in Azure, S3 buckets in AWS, AWS launch configurations, loads of different pieces that you cannot create a new one before you delete the old one. And if you're trying to use a strongly typed name, then of course at that point you can be in some problems because the name already exists and it won't allow you to do it. So by default, Pulumi will actually auto name for you. We're going to say no here, and then I can actually override that and I can call it bucket, and I can say NDC Oslo 2020 demo. So we're actually strongly naming the bucket right now. So I go back to Pulumi up, and of course Pulumi up this time will tell me that it's going to create the bucket with the exact name that I specified. In 1 second. Please, there we go. And we can see it's an NDC Oslo 2020 demo. And let's roll that bucket up. So Pulumi now has that in its state. I can promise you that this specific account has hundreds of S3 buckets, but this Pulumi application itself only cares about this specific S3 bucket and nothing else. I really hope somebody else hasn't snagged that bucket. There we go, it's created, good. And we get the bucket name back. So if I say Pulumi stack export, we can have a look at the state that it actually holds. And just to show you that we don't store any credentials, it has the manifest number. It has the secrets provider, the secret provider just being that we're actually logged into the service. It doesn't store any credentials or any way, shape, or form. And there are no S3 credentials, actually, AWS credentials being stored in our state file or transmitted in our state file. This JSON blob is everything that is being pushed to our state, our metadata server, and nothing else. And we can see that it's created the bucket and it has all of these specific outputs that come with it. Okay, so we can add some tags to it. Tags, and we can say owner stack 72. And the next Pulumi up, it will actually only tell me what has changed because it has the state, it understands what the state is currently in our application. And it will tell me that it's going to change the tags, and we can have a look at the details, and it's only going to touch the tags and nothing else. And then lastly, if I destroy it, because this is not interesting, this part of the demo, we can see it's only going to destroy that specific bucket and nothing else within this account. And we can say yes, that goes with that. So that is the most basic flow of a Pulumi provider. Okay, let's go and write some more interesting code that actually is a little more useful. So I have some code that I've already written, and let me just grab it. So the first thing that we need to do is I am going to create a number of resources. Okay, again, please don't laugh at my JavaScript. I promise you it only gets better. I can't actually get any worse with JavaScript, but that's okay. So we have, firstly, we go off to AWS and we get the AMI for a specific Ubuntu image that we want to launch a machine on. Then we have an SSH key. Please never do this in production where you embed your public key in your infrastructure. Then we have a security group that goes with it. So let's say that we actually want to launch multiple web servers here. This is why I love JavaScript as a demo, because I can say let web servers equals an empty unbounded array. And I can actually say okay, so we're in a real loop right now. We can actually take advantage of all of being able to loop and taking care of everything inside the ecosystem. So we're going to say we need to usually do something like const web server equals new AWS .ec2 .web server, or excuse me, .instance. Our instance will need to have a unique name for everything in the loop, okay? Just because that's how Pulumi works. Every part of every individual resource needs its own unique name. So here we're just going to use the number, which will be X. then we can actually say our AMI will be Ubuntu.id. We're actually getting full IntelliSense the whole way around. Look, we're missing our instance type. We're missing some other things. I'm going to say our key name is our key name. I'm going to say our VPC security group IDs are our open security group.id. And I'll come back and I'll show you in a second what's wrong right there. And lastly, our instance type, let's do T2 medium. Okay, just because I know that that's the case. Now, usually this would look okay code and you would actually run your tool and it would actually come back with an error in the tool. We know Pulumi understands straight away that a string is not assignable to an array. So we understand that this actually needs to be an array. So Pulumi has given us, only because of the fact that we're using real languages, it's given us the hints as it goes along. And then lastly, we can say web servers.push, and we can small lambda x dot public DNS, public IP. And then lastly, we can export const web server IPs equals web servers dot map. And you can actually pull the information out of it. Now, this is a little bit painful because we need to declare and we need to actually push individual pieces. So what we can really do is we can web servers.push the entire instance into the array. And then I can say web servers x dot, and I have full access to everything inside here using the individual map. And of course, my autocomplete's giving me it. Now, if I went and ran that, let me just show you Pulumi up here. It is going to tell me it's going to create 100 instances plus the stack. And of course, because the instances have no relationship between each other, it can do all of those instances at the same time. There we go. So it'll create 103 resources in total. We're going to say no. So that's not really of use. Let's actually take advantage of, not everybody knows each and every individual piece here. So what we can do is we create our own individual component, and I can say webserver.ts. And my webserver.ts would do the following. So I can import star as Pulumi from Pulumi, and I can import star as AWS from @Pulumi AWS. Okay. Now Pulumi, this is TypeScript, so we can take advantage of inheritance. I can actually export a class, and not just inheritance here, but of course real programming constructs. I'm not taking advantage of custom resources right now. I can say export a class, which will be web server. Web server itself will return a public read-only VM, which will be of type aws.ec2.instance. And then we need a constructor. The constructor will take a name, which is of type string. It will take an AMI ID, which is of type Pulumi.input string. I'll explain that in a second. And lastly, it will take an instance type, which we can just pass in as a string. So we have our class set up. Everything is working as expected. And then I can say this dot VM equals new aws.ec2.instance. We will actually say that the instance will be name. And we can say the AMI ID is our AMI ID. We can say our instance type is our instance type. And then I'm actually just going to move some of these files just to make it nice and simple. I'm going to move security group and SSH key because they can be specific to this individual class itself. And I'll just embed them in this file. I can say our SSH key. Key name, I apologize, is SSH key dot key name. And then lastly, I can say VPC security group IDs is open security group dot ID. Now, of course, this is telling me straight away that this is actually not the correct type because it needs to be an instance type. So we created this, this helper class, which we can say aws.ec2.instance type. And I'll show you that in action in a second, which will now mean it is assignable as expected. And everything works and all of the code works as expected. Now, instead of creating a new EC2 instance here, what I can actually do is I can say new web server. Now notice my IDE will not, there we go, there's our import statement. So we're importing web server from the web server class. We will pass in web server $$X, and it takes like 2 more parameters, which will have an AMI ID. It needs to be Ubuntu, I apologize, Ubuntu.id. Then it needs to be AWS. I told you before, like we created this helper layer for instance types. So we can say aws.ec2.instance types dot, and we get autocomplete for all of the instance types inside AWS. And that works as expected. And notice that our IDE has told us, wait a minute, this isn't correct because public IP doesn't exist on X anymore because X returns a VM, which has public IP inside it. So straight away, we've been able to refactor and actually push a number of pieces of components down into the web server class that can be packaged up and it can actually be distributed amongst developers or operators or whatever. So creating those layers of abstraction are nice and simple. Let's do something more interesting. Let us have a look at the secret management of Pulumi. So the first thing I need to do is I need to install at Pulumi, and I'm going to say random. So random is like it suggests, it's a package that allows you to create random strings and random pieces of functionality, and importantly, random passwords that are of like, you know, different character strengths and things like this. So the first thing I'm going to do is import star as random from Pulumi/random. Okay. Now I'm going to say const my password equals new random password. I'm going to say demo1, and I want that password to be 30 characters and have special characters, special true. Okay. Now what we can actually do, and this is how most tools work today, I can const password value equals my password, and I know that this is stored in result. And if I go and I run Pulumi up, and I'm going to say yes here. So I'm going to skip the prompt, which actually asks you for yes. And I'm going to say skip preview. This sort of puts Pulumi into the CI mode where it doesn't have any interactivity that comes back at all. And what this allows us to do is we actually get a password that will be prompted and pushed out, and you can see that it's in plain text. Now, I told you Pulumi was secret by default. We actually have a secret provider enabled. And if I do exactly the same thing with a second random password, the third argument to the resource is called custom resource options. And inside here, we can actually take advantage of additional secret outputs. And it's stringly typed right now, but that could change in the future. And this allows us to be any outputs of that name. So result from the parameter, the output parameter result will be treated as a secret. There are a lot of interesting extra things in here. So you can actually mark things as delete before replace, import if you have existing infrastructure. You can actually protect your infrastructure so that Pulumi will never destroy it. Ignore any changes that happen in your infrastructure. You can version it, you can have aliases, custom timeouts, everything, right? There's a lot of different things in here. But for now, we're just going to say the output will be result. And I'm going to say my password2 is my password2.result. Now, if I run the same, you'll see the first one comes back as normal, as the unencrypted string, but you'll see the second one is actually secret. And even inside Pulumi state, we will see that it is stored as secret. We can see the ciphertext right here. Okay, this is using Pulumi KMS, like I told you, because it's there. But when I Pulumi stack init to create a new provider, you can very much pass in your own KMS ID, your own Azure Key Vault, or GCP KMS, or of course, if you use HashiCorp Vault, we can use HashiCorp Vault as well to do that. So for us, this is extremely important. But you don't just set secrets that way. So let's say we need a password that is going to be used inside our application. So if I say Pulumi config set my database root password, and it'll be password 1234 exclamation mark. You need the exclamation mark unless it's secret, to make it secret. And we can see that by default, Pulumi doesn't know that it is a secret. So we can pass the same, and we could say with secret, and we can see it has been used as a secure string. Now, it's really important to show you one thing here. So if I import star as Pulumi from @Pulumi, then I want to show you that we actually pass it around as a secret the whole way through. Okay, we don't decrypt it and then use it. It's actually only used at the point of execution is when it's actually decrypted and passed around. Otherwise, it is a secret, and I'm going to show you that. So const my db password equals config.getSecret. And the secret that I called it was my database root password. And then lastly, I can export it. Export const x equals that. And if I Pulumi up right now, we will get the correct behavior, which will pass, and we will see it coming back. X is a secret. And of course, more importantly, is X is stored as a secret in our provider. There we go. It is stored as a ciphertext. So everything by default, the outputs are all stored as ciphertext, and you can push as many of these in as you need. So as well as result, we can pass length, we can pass special, so nobody can actually see if it's a character that's been encrypted with special characters or how big the password is and so on. And Pulumi will store all of those. And one last time, we can have a look at it. And there'll be no changes because all it's doing right now is changing the state and nothing else. We can see that there are 3 unchanged resources. And if we go back to our state, we can see that special is now encrypted, result is encrypted, and length is encrypted. So you can encrypt any output parameter that you require in order to keep your state as safe as possible. So that is secret management. Secret management for us is extremely important. Okay, so I'm just going to destroy that application right now. Let's go to something a little more. What have I got? 20 minutes. Okay, perfect. I have a lot of time. I have a lot of time. So let's actually go in and create something a little bit more interesting. For those in AWS, if you know in AWS that secret management is, or excuse me, IAM management is painful because you actually have to use JSON blobs everywhere. So this shows the ability of how Pulumi can actually abstract that away from you. So I usually, in person, I would give a prize for the person who can help me code this. Hey folks, I'm really sorry. I didn't realize I was kicked out. I asked if everyone could hear me and they said yes. So I don't understand what happened. I apologize for that. So what I was actually showing is I was, where was I up to? So I was showing that we were able to create a layer of abstraction around an API gateway and hook a Lambda function up to the API gateway with the correct permissions that Pulumi would package the API gateway for us. The API gateway actually, the Lambda has code in it that talks to AWS DynamoDB because we have imported this AWS SDK package, Pulumi understands that it needs to include that as a reference within your Lambda. And lastly, it actually will expose that Lambda when somebody makes a GET request to the /route on the API gateway. Okay, so in the code, what that actually looks like, and it looks like IAM is down right now, but I'm still hearing people maybe talking to me. Can you? Oh, good. I thought that was like, can everyone hear me? Yes? Okay, perfect. I don't want to be kicked out again. So we can actually see that it's packaging and building the software as well as our infrastructure at the same time. And that's extremely useful because as a developer, we maybe don't care about all of the individual components that are required in order to get our Lambda into the cloud. Let this specific package that has been created deploy this for you. Now, it looks like this deployment is not going to happen because IAM is still down, I believe, and it won't allow me to roll out the IAM. But effectively, what I would be able to do then would be to make a curl request to the slash endpoint of the URL. And the URL I actually have outputted from the site that has been created, and it would actually see the hits actually triggering up. So it's extremely useful in terms of doing that. But what we can do is we can cancel it, and then we can actually see Pulumi's actually telling you if you terminate it, it's going to give you orphan resources. So we don't care. We'll just say Pulumi cancel to cancel the update. And then lastly, oh, there we go. Update has completed. I'm just going to destroy the infrastructure that goes with that. So the serverless layers of abstraction is extremely useful here because it gives us the ability that we can actually do different things. So let me just go into another folder, demo testing. I have one last demo because I have 5 minutes. Demo testing. CD demo testing. There we go. I'm going to scaffold a new Pulumi application. So Pulumi new AWS TypeScript. And I'm going to say yes. And you can see it chooses the defaults for me. But I'm going to override the configuration of the region. So Pulumi config set AWS region is US West 2. I'm going to install another package. So npm install at Pulumi. And the Pulumi package is a layer of abstraction around EKS, which allows us to create Kubernetes components. And I'm going to install that. I'm going to create a folder called tests. I'm going to go inside the tests folder, and I'm going to scaffold a new Pulumi policy pack, which will allow us to run the tests. So Pulumi policy new AWS TypeScript. And that just sets up some basic like configuration that allows us to do different things. And I just need to add some code in here. Okay, so the first thing I'm going to do is I am going to open my IDE. Okay, so my IDE will allow me to do a number of things here. So firstly, in tests, I'm going to kill everything that's in here, and I'm going to write a policy test. Okay, this is policies that will always apply to the code every time you try and deploy the code. Okay, and what it is I want to verify that a specific version of EKS has been deployed